Welcome friends to my YouTube channel. Now on my last lecture I have discussed about the collision process. Okay, and there we find the velocity after collision in a simple algebraic manner. Okay, by assuming that the collision is elastic. Now in today's lecture I shall going to discuss the energy loss energy loss due to collision. Okay, so we have seen that initial kinetic energy, say this is particle of mass m1 and this is m2, and both are approaching towards each other, and after collision they move in opposite direction. Okay, that means if before collision u1 in this direction, after collision it will be in the opposite direction, and after collision v2 will be in the opposite direction. Okay, so in this case the initial kinetic energy will be simply half m1 u1 square plus half m2 u2 square. Okay, so what will be the final kinetic energy? The final kinetic energy will be half m1 v1 square half m2 v2 square. So what will be the loss? That means initial minus final. So loss of energy will be simply half m1 u1 square plus half m2 u2 square minus half m1 v1 square plus half m2 v2 square. Okay, now if we take m1 by m2 common, then simply we can write this m1 plus m2 into m1 u1 square plus m2 u2 square minus m1 plus m2 into m1 v1 square plus m2 v2 square. Okay, so we can write this. So we have to do little simplification. We have to do little simplification. That is, this is 1 by 2 m1 plus m2, and if we multiply this, that is m1 square u1 square plus m2 square u2 square plus m1 m2 u1 square plus u2 square, and this is simply m1 square v1 square plus m2 square v2 square plus m1 m2 into this is simply v1 square plus v2 square. Okay, now this is simply 1 by 2 m1 plus m2, a square plus b square we can take it, a plus b whole square minus 2ab, 2m1 m2 u1 u2. Okay, and that a square plus b square we can write a minus b whole square plus 2ab. Okay, similarly this a square plus b square can be written as a plus b whole square minus 2ab, and this a square plus b square we can write a minus b whole square plus 2ab. Okay, okay, now simply 1 by 2 m1 plus m2, this is 2u1 u2 m1 m2, and this is 2 m1 m2 u1 u2. Here this is minus and this is plus, so both are cancels. So we can write m1 u1 plus m2 u2 whole square plus m1 m2 into u1 minus u2 whole square. Okay, and here also 2 m1 m2 v1 v2, 2 m1 m2 v1 v2 cancels, so we can write m1 v1 plus m2 v2 whole square plus m1 m2 into, this can also be written as v2 minus v1 whole square, since there is a square term. Okay, so we can write in this manner. Now we all know that whether the collision is elastic or non-elastic, no matter, the law of conservation of linear momentum holds good. Okay, so whatever may be the type of collision, the law of conservation of linear momentum holds good always. That means m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So this cancels. Okay, so what we can write, 1 by 2 m1 plus m2. Okay, and if we take common m1 m2, there will be u1 minus u2 whole square minus v2 minus v1 whole square. Okay, that we can write. Now what we can write from Newton's collision rule, we all know that E, this is simply velocity of separation divided by velocity of approach. So what we can write, v2 minus v1, this is simply E into u1 minus u2. So if we substitute it, m1 m2 by 2 into m1 plus m2, so this is u1 minus u2 whole square, this is minus e square into u1 minus u2 whole square. Okay, so m1 m2 by 2 into m1 plus m2, if we take u1 minus u2 whole square common, then the result will be 1 minus e square. Okay, so this gives a name. So this is the general expression of energy loss. Okay, the general expression of energy loss. Now let us take the special cases. So if the collision is elastic, we can write E equals to 1. So if we put E equals to 1, so that means the energy loss is 0. Okay, the energy loss is 0. That I told earlier, that in elastic collision the energy remains conserved, so there is no loss of energy. So this is the answer. So if we took the perfectly inelastic collision, then E is 0. So if we put E is 0, so we see that the energy loss is maximum. This quantity remains, that means energy loss is maximum. So we have find out the general expression of energy loss due to collision, and we also find out the special cases. For a perfectly elastic collision, E is 1, and that for perfectly inelastic collision, E is 0. That means there is a maximum energy loss. Okay, that is maximum energy loss. Okay, so in today's video I shall discuss about the energy loss due to a collision, and in our next video we will discuss about few other issues related to collision chapter. Okay, so if you like my video, then kindly subscribe it. Okay, and video link will be given in the description box. Okay, thank you.